Hi, Assalamualaikum. My name is Nur Shafinas Izzati binti Suyami, and my members is Muhammad Luqman and also Siti Norbaiti. We have done a research on image processing for mango grading, and we would like to share our findings in this presentation. The content for this presentation is to talk about introduction, literature review, methodology, results and discussion, and also lastly conclusion. Background of this project: the demand for a quality mango fruit is considered high as the fruit is really delicious and nutritious. Thus, a functional system for mango fruit grading is really suitable to be implemented to filter the best fruit from the farm. Traditionally, fruit grading by human is less efficient and sometimes lead to error by just following their judgment or instinct only. This project is introduced to get quality mango fruits by identifying its color, measuring the size, and also detect any black spot on the mango fruits. Then, a sorting process is implemented where the image of the fruit is captured and analyzed using image processing techniques to classify each status of the fruit. The chosen mango for this project is Nam Dok Mai mango. Nam Dok Mai mango is originally come from Thailand, and it have uh, it have one of the general variety of mango that commercialized in Malaysia. Commonly, this mango is eaten with sticky rice. And the disease detected for this experiment is bacterial canker, or which is also known as black spot. And the aim of this project is to study the process of fruit grading based on ripening and defectiveness of the fruit by imaging processing. The problem statement for this experiment is having a problem to check the quality and classify the fruits, and also time consuming to check the defectiveness of mango due to a large scale. The last problem is the tendency to the inaccuracy of result increase and causing higher loss. There are three objectives for this experiment, which is the first one to do research on the existing technology used for the identification of mango disease and classification, and also to determine the specific portion of the fruit item is affected or not, which is the black spot, and the last one is to develop an existing method in modern agriculture. The next is literature review. There are several literature reviews to support our finding, which is the first one is from Dr. Pushpa Bali. He done a research and proposed a fruit grading technique of mango fruits by using machine vision approach. And also he is observing its color, size, and also weight. From this process of the fruit grading, we can detect any defective fruits which are really efficient. The second literature review is from Rokonuzaman. He also has done a study, use machine vision system for sorting the defected tomatoes. And also he used image processing technique to sort and make a decision on the condition of the tomatoes. And the last one is from Mustafa. He also done a study for vegetables and fruits to choose based on their shape and also size using a support vector machines.
Hello, my name is Luqman. My matric number 19002. For the methodology part, I will present a little bit about our project. So the software that we use is MATLAB. And our grading criteria will be the color and the condition. For the color, we will categorize the green and yellow type of mango. For the green type, it will classify as unripe, while the yellow type will be the ripe mango. And for the condition part, it will show if the mango show dark spot, it will classify as a defect mango. While if the outer layer part of mango doesn't have dark spot, it will be the good type of mango. Next, for the color, the method we use will be the color segmentation of the fruit, where the green and yellow will be differentiated. And the method to determine this color will be by calculate the RGB mean value of each color between the green and yellow at each color bands. And as for the condition criteria, the method we use will be using the K-mean clustering algorithm, which is the way to segment image into 3 clusters and determine the cluster with highest intensity of the black spot, which is the damaged part. And for the flowchart, we'll start by taking the image and go through image pre-processing and image segmentation and feature extraction, which I will explain later more. After that, we just calculate, just process to differentiate whether it is defective or not, and then proceed to the ripeness of the fruit, and then we display the fruit status. So back to the image pre-processing, it is used for identify and classify of the image, so we can recover a good quality of image. So the steps that we use will include background subtraction, convert RGB image to grayscale, and then to binary image, and then the filtering to get a quality image. And the next process is image segmentation. It will be used to divide image into meaningful regions only. That with respect to our what we need, like what we need is just the mango, right? No, we don't need the background. And then the step that we use is based on the measurement taken from image, like its color and the texture. Then the characteristic in image were separated during segmentation, which include color or intensity-based segmentation and region-based segmentation. For the feature extraction, we use to filter large dataset from initial input, and then we calculate image color distance to right and get to detect any defect available on the fruit. So the step we use is the defect category will be divided by its ripeness and presence of dark spot, which tells that the fruit is already spoiled.
The mango grading. So first of all, we will read the image. Then after the image are read, color segmentation process are done. After color segmentation process are done, the image are masked into 3 individual color channel, R, G, and B, and then the R, G, and B reference color for ripe, unripe, and black are inserted. So in this case, the ripe color are defined, the RGB value for ripe color are defined as 201, 165, and 2. For the unripe color, 116, 158 and 48. For black color are 0, 0 and 0. And then after that, the RGB individual color channel from the image are extra. And then the mean color for RGB on each block are detected and are extracted too. After that, we will calculate the color distance of the image color to the color reference of ripe and unripe. If the distance to ripe are less than to the distance of unripe, so yes, therefore the TST value will be ripe. If no, the TST value will be unripe, and then we will get the TST value. After that, we will calculate the image color distance to the black reference. So if the distance to black are less than 230, therefore the C and D value is good. If no, we will test for the distance to the black if it is in the range of 230 to the 270. The C and D value will be rejected, else the C and D value will be good. Therefore, after that, we will get the C and D value, and then lastly, we will display both TXT and C and D value in the message box, and that's the end of the process. So in the previous video, we have demonstrated the input and output for mango grading process. So in this part, we will explain more detail in how the working process. So first of all, we will read the mango image or the demo image using here the imRead function. Then we will do color segmentation for the mango image. Color segmentation process is where we will obtain the individual R, G, and B color channel for each individual channel. Then after we do color segmentation using BW area open, we will obtain a larger blocks, and the blocks are considered as mango. So here I put the value of the pixel is anything that higher than 1000 is considered as block in the image. So after that, we will extract the individual red, green, and blue color channel using RGB image. Here are the channel 1, 2, and 3. And then after we extract the individual red, green, and blue color channel, we will obtain the mean color for each block. So supposedly we actually can only get one block, but sometimes if the image are not clean, we may also get higher than one block. So after that, I've defined the reference color for ripe, unripe, and black. So ripe color are for ripe mango, and then unripe color is for unripe mango, that which is near to the green, ripe is near to the yellow, and then black color I only state 000 as totally black. And then after that, we will find the distance from this color. This color is actually indicate the mango in the image color to the reference color, whether it's ripe or unripe. So here are distance to ripe, and this one is distance to unripe. So after that, we will display the value for distance to ripe and distance to unripe. So then we will conclude if the distance to ripe is less than distance to unripe, the TXT value will be ripe. Else, if distance to ripe is larger than distance to unripe, then the TXT value will be unripe. Following for the rejected and good condition, we will also use the same way as we used to define ripe and unripe. However, in this part, the distance to black are set to either if 83 are less than distance to black and distance to black are less than 230, the C and D will be good. Else if 230 are less than distance to black and distance to black are less than 270, the C and D will be rejected. Else, it means if it is higher than 270, the condition will be good. The reason why I do range value for black is because the range from 83 to 230 are what I get from the unripe mango, and anything that higher than 270, the distance this color distance to black are for ripe mango. So the only value that I get for rejected mango is if the distance to black are 230 and 270 for the this color RGB value from the mango. So finalize it is we will display the message box that will print off mango status equal to the TXT, whether it is ripe or unripe, and then the CND, whether it is good or rejected. So first I will test it using the unripe mango. So this is the unripe mango. In here, the status output are unripe and good. So then next, so from the common window, we can obtain the value of this color distance from ripe to unripe. So here we can see that for block 1, the distance to ripe are 186 and the distance to unripe is 105. Therefore, the distance to unripe are more shorter than as compared to the distance to ripe. So that's why the message output we get unripe. So as for black, the distance to black, the lowest distance to black in this block is 73 and 87. So that's why in the condition for distance to black, I put it as a 3 range, and then in order for mango to be defined as rejected is that if the distance to black is 230 to 270, because if it's lower than that, the value are for unripe mango. So next we will test it with ripe mango. So here I will change it. So this is the image for ripe mango, and then the status output are ripe and good. So from what we can see is that for block 1, the distance to ripe is 65 and the distance to unripe is 94. Therefore, the distance to ripe are less than the distance to unripe. That's why the TXT value is right. And for the distance to black is 277. So it is higher than 270. That's why the C and D output are unripe, because it is not in the range of 230 to 270. Next for next we will test it with the rejected mango. So here the rejected mango. So the status info is ripe and rejected. So it's correct. So in the command window, we can see that for block 1, the distance to ripe is 56 and the distance to unripe is 75. So the distance to ripe is less than the distance to unripe. That's why the TST value is ripe. And for block 1, for distance to black, the value is 238 and it is higher than 270. That's why the C and D value is rejected. Is rejected because it is in range of 230 to 270. So that's all from me for this. So next we will move to the conclusion by Shafinas.
Okay, next, we have come to the end of this presentation, which is conclusion. In this project, the aim is to study the process of fruit grading based on ripening and the effectiveness of the fruit by image processing has been achieved. As mentioned in the proposal before, the aim is to study the process of fruit grading based on size is failed to achieve due to some limitation such as the size of mango cannot be seen clearly in the picture unless the mango is placed side by side. Therefore, we decide to limit the objective of this project and only achieve three main objectives. This project helps to reduce the work of human and time consuming as well as to identify the fruit based on the quality in image processing using MATLAB as an interface. The purpose of this project is to solve problems faced in sorting the mango based on ripeness and effectiveness is achieved. That's it from us. Thank you.